In this lecture, we will discuss complexity classes. In complexity classes, we will discuss different type of function. Function will be decreasing function, constant function, logarithmic function, polynomial, and exponential. We will discuss their which is greater than which, and we analyze some more classes. First, we will discuss decreasing function. First is decreasing function. Decreasing function. In decreasing function, we are discussing for time complexity and space complexity, and time complexity and space complexity can't be negative. So in complexity classes, first we will discuss that decreasing function, because in time complexity and space complexity, only decreasing function can become, or any other function, or we can say that not negative function will come in complexity classes for space complexity and time complexity, or for any problem. Okay, decreasing function is nothing but it can be n by 1 by n, 1 by n square, or 1 by n cube, or log n by n, or n by n square, or n square, or 2 to the power n by 2 to the power n. This is same as, because if we cut, it will give 1 by n. Okay, next we have another function, that is constant function. Constant function. Constant function. Constant function that can be 1, 10, 20, 50,000, or 1 lakh, or etc. And the problem in constant function, that it will start from, if we start from 1, at end the value of function will be 1, or if we start from 50,000, 50k, or 1000k, at the end the value will be again same as it started. Another is, we have logarithmic. Logarithmic function. In logarithmic function, we have log n, log n, log n square, log n, etc. No, thereafter we have another function, that is polynomial. Polynomial function. Polynomial function. In polynomial function, we have n to the power 0.1, n to the power 0.5, n to the power 1, n to the n square, n cube, dot, or we have n to the power 2.5, or n to the power 25, or etc. Okay, here its a general representation is n to the power c. Okay, and where c is constant, t constant, and c is greater than 0, and here this and this and this, these three function which are under polynomial function, there we have a special name, that is n to the power 1 is nothing but its linear. Linear function. It is nothing but quadratic. Quadratic, and this is cubic. Cubic. Okay. These all are under polynomial, but their special name are given. That is, if n to the power 1, then it will be linear, and n square is quadratic, and nq is cubic. This is a 4 type of function, and another is exponential. We have another type of function, that is exponential. Let's take. Let us understand exponential. That is fifth. Exponential function. Exponential function. In exponential function, 2 to the power, this is in general. In general representation, of polynomial function. Where c is greater than 0, and this is 2 to the power n, 3 to the power and n, and 1.5 to the power n, or 7 to the power n. These are the example of exponential function. And in general, we can write some constant to the power n, and this constant should be greater than 1. C is constant, and c is greater than 1. So this is the 5 type of complexity classes, and these are non-negative complexity classes, or in for time complexity and space complexity we discuss only for non-negative. So these are the 5 type of complexity classes. Now there are some more function which are greater than exponential function also. First we will create one diagram and try to understand which is the highest, and growth, we will discuss growth of each function. We will create a roughly diagram. Okay, let's try to create a rough diagram. Here n, and here f of n, or g of n, any function g of n. There in this axis the function, and in this axis there will be n, that is the number of input. Then first we have constant function. Starting from, if we start from somewhere, then at end it will live at that point from where it started. Next we have logarithmic. First logarithmic function will be less than constant and slowly it will increase. Slowly it will increase. Next we have linear function. It is logarithmic. This is for an n. This will logarithmic function, and thereafter we have quadratic. That is n square. Thereafter we have n cube, and thereafter it will some polynomial function. Polynomial function. These all are polynomial function, but for n square and n cube, a special name are given. Then we have exponential classes. Exponential classes, that is some constant to the power n, some constant to the power n, and c should be greater than 1 for this. This is exponential classes. Exponential. Okay. Now we have one more class which is greater than exponential also. That class is if we write 2 to the power n and n to the power n. Now which is greater than? Actually 2 to the power n is nothing but it's a exponential function. Then n to the power n. Now which is greater than? This is nothing but 2 into 2 into 2 into 2 dot 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 n time, and here n into n into n into n dot dot dot, it will also for n time. Okay. Then which is greater than? Here every time 2 is multiply n time, here n is multiply every time. So if we take n naught, or here n is greater than equal to 3, or we can call it n naught actually, and if we take n as 3 or greater than 3, then definitely this will greater than n to the power n. So this will come here, that is n to the power n. We have one more function, that is n naught. This is factorial of n. Where this will come? Actually this here, this is nothing but here, this is nothing but n into n minus 1 into n minus 2 into dot 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 1. Now here it will multiply n time, and every time 1 is decreasing. So this is lesser than this, but it is greater than this, because only one term, that is 1, is lesser than to the power n, but all the term, that is n minus 1 term, all our term is greater than or equal to 2. Okay. So n factorial will come before, n factorial will be greater than, n factorial will be greater than 2 to the power n, and n to the power n will greater than, is greater than n to the power, n to the power n is greater than n factorial. Okay. And to discuss which function is greater than equal to another function, we will try to use some proof, and don't go for substituting the value. If we substitute some value, for example, if we take some example, let's take 2 to the power n, and one more example, which or n to the n square. Now discuss, this is end of this story. Now we will discuss about which function is greater than and how we find that one function is greater than another function. So for this, remember this is an important point, that n to the power n is greater than n factorial, and n factorial is greater than 2 to the power n. 2 to the power n is nothing but its exponential function, and it is not necessary that for every function we have some name. So this is I am not giving any name for this function. This is greater than 2 to the power n, and somewhere n factorial will come here. Okay. Now if for example, if we want to put some value, and then we will try to find which is greater than another function. If we write n equal to 1, then this will give value 2. If we take on n equal to 1, and this will give 1. If you take n equal to 2, then this will give 4, and this will also give 4. If n equal to 3, then this function will give 8, and this will give 9. But if n equal to 4, then this will give 16, and this will give again 16. Okay, no problem. We will go some more increase value, n equal to 5. Now this will give 32, and this will give 25. Now game is over. That n square is lesser than 2 to the power n. So if you want to substitute value, then put larger value, and this is not the right way to discuss that which function is greater than another function. To discuss, go for some proof. For example, if there for example n square and n, if we want to discuss which is greater than, then n into n, and here n, cut 1 here n. So this is clearly n is greater, so n square is greater than 1, n is greater than 1, so n square is greater than n. So this is nothing but this is the proof, and go for proof, don't substitute. And if there is no any way to prove by, or there is no anything similar, then you can substitute, but substitute higher value. Okay, we will discuss more in this topic. Use logarithmic log also for discussing which is greater than or which is lesser than in next video. But in this video we can discuss that somehow decreasing function is list among all these function. Now I am summarizing all of decreasing function. Decreasing function is lesser than constant. Constant is lesser than logarithmic, and logarithmic is lesser than polynomial. In polynomial there is first linear, polynomial. First linear, then quadratic, then cubic, then actually polynomial for any. This is nothing but n cube, and there can be polynomial. Cubic is less than polynomial. In polynomial classes, this linear, quadratic and cubic are under polynomial, and in polynomial linear is less than quadratic, is less than cubic, and cubic is less than polynomial. That is polynomial should be greater than n cube, actually greater than n cube, that can be n to the power 4 to infinite. Okay, and polynomial is less than exponential. Okay, this is the complexity classes, that exponential is greater among all of these, but there is more some function which is greater than exponential also. Okay, next we will discuss in another video. Thank you, and if you have any confusion you can write on comment box. Thank you.